Hi again, everyone. In this quick demo, I'll introduce a bunch of new stuff that we have added to Spike mainline. First of these is we added make files to group the related tasks together. Because Spike is a Go project, and make files are typically how you manage project related tasks and automation in typical Go projects. So we said, instead of dumping everything into a big hack folder, it will give some more organization to have make targets that are like purpose specific. So we have some of those. I'll show them and we'll add more as we develop the project. Other than that, we have a test application, like a test workload that can consume secrets and that can even write secrets when given enough privileges. In the last demo, I wasn't able to show it because the workload didn't have the policies attached to it, and also the workload didn't have a spiffy ID link to that to enable it to communicate to Spike API. So let's get started. Let me open the project folder first. So this is our makefile, the makefile under the project root. It's down here, and it has several targets. So this start initializes a testing environment that you can use to experiment with Spike. I'll go into the details of the script to show you what it's doing, but essentially it initializes a Spire server client combo. It creates a trust relationship, and then initializes Nexus and Keeper for Spike to be able to be serviceable. So let me go through that one, and I haven't merged it yet, but it is working. So you are seeing into the future. This is not part of the main line, but it will be soon after this demo. So I have a bunch of background helper scripts. Let me show them as well. Let me go to this hack folder, lib bgsh. So I have a cleanup function that cleans up a list of background process IDs when we exit the script. And we have a run background helper that runs a script in the background. I'm using it so that I can run Spire server, Spire agent, Nexus, and Keeper all together as part of a single script. Otherwise, I have to open separate terminal windows. And this background runner dumps the process's output and input to a log file in the root folder. So if there is any issue with your startup, you can just tail that log and investigate. So that's that part. So essentially, in a nutshell, what it does is we clear former data that we might be keeping as part of an older experiment. We build the binaries, and those binaries are, let me show you, the Keeper, Nexus, Spike, and also the binary of the demo application. All of those 4 binaries, that build binaries script builds it. After that, we create Spire server, initialize Spire server. Spire server generates an agent token to establish trust relationship between the agent and the server. Then, when we start the agent, we'll use that token to prove that it's what we claim to be. We register certain entries, certain S-Suite entries to Spire server. Those entries are for Spike Keeper, Spike Nexus, and let me check what they are actually. Register entries, Spire server, register, I'll find it, entry register Spike. So we create one entry for Keeper, another entry for Nexus, so that Keeper and Nexus can communicate with each other. Then we do the same for the super user that we are using on this machine, so that we can use Spike binary. Without the SU entry, you won't be able to execute Spike binary and create secrets or list secrets, all of those secret management tasks. You need a registration entry to be able to do that. Uh, then we initialize the agent. Then, like I said, we run Spire agent. After that, we start Keeper and Nexus, which will initialize our entire Spike stack. And then the script will say, hey, everything is fine. You can cancel this script whenever you want. And when you cancel it, it will clean up all of the processes and things will be back to where it has been. So that's that part. I'll open a separate terminal window and show you folks how that works in practice. I'll go to my desktop workspace and then Spike. If I make tab, then it will show like the available make targets that I have. So I have like my start, make start, and also I have demo workload related tasks. I'll show the scripts associated with them so that when the time comes we can execute them. Let me go here, go to the hack folder again, server, register. So the demo files are under this example under this examples consume secrets folder. So like I'm segregating these folders as per use cases. So this script is for like the multiple server use case demo that we have recorded a while ago, and this is for using policies and policy driven secret management. So this demo register Spire entry, for example, will create a SPIFFE ID for the demo so that the demo application can talk to Spire SPIFFE workload API. The create policy creates a read and write policy for a certain set of secrets that will be registered under a path. So for all of the secrets that is under the tenant's demo DB path, we have read permission and also write permission to any application that is registered itself as a workload, as a SPIFFE ID that has workload in it, essentially. So that's how we enable policy-based execution rights to apps. So without these policies, the app will not be able to talk to the Spike APIs, and we'll see it shortly when we start demoing. Without further ado, let me start run the starter script and show you how things work. So I'll do a make start, Control Enter. It will build things. It will start like Spire server. It will register a bunch of entries, and then it will ask me for my password. I'll enter it, and now it will start the Spire agent. Then it will start Keeper and finally Nexus, and it will be ready for operation. I'll wait for it to complete so that I can run the rest of the Spike. So this is running all of the processes that we want. So I can search into it. Like if I do ps aux grep Spire server, I have a Spire server running. If I do a Spire agent, I have Spire agent. If I want to search for Nexus, I have a Nexus, and a Keeper, I have a Keeper. All of them are up and running. So if I do Spike, I will be greeted by a helpful documentation, command line instructions, so to speak. We should run Spike init to initialize the trust material so that we can use Spike. Otherwise, it will complain. So let me show it essentially. If I do Spike get tenants acme db, it will say, Spike secret get tenants acme db. It will say please initialize Spike. So I'll do Spike init to follow its suggestion. So we initialize our secret store. Now we can test the demo application, because while running the starter script created the binaries that we need: the Spike Nexus, Spike Keeper, and also this demo app. So the build script will build the Spike Pilot, Spike Nexus, Spike Keeper, and our demo application. The script that handles that compilation is the make start script that we run. So when we run make start, all of these applications, let me show you, all of these applications will be built as binaries. So let me go to my terminal and run demo. So right now it will wait forever, hang up, because there is no SPIFFE registration entry for the demo application. So it will wait and not be able to connect to the SPIFFE workload API, and therefore it won't be able to fetch secrets from Spike. So to rectify that, let me do make demo register entry, and it will create the Spire registration entries, SPIFFE, that it will create registration entries on the Spire server. So when we run demo again, it should wait a while, and then it should give like a hey, I cannot write a secret, I am not authorized, because although we have given it the ability to talk to the Spike Nexus, we still do not allow it to read or write secrets. There are no policies tied to the demo application to be able to do those operations. And those are, so this policy create workload can read and policy create workload can write. These are the two policies telling the demo application, actually telling Spike server, Spike Nexus, that it can accept requests from the demo application to read secrets in a certain path or write secrets to a certain path. So for all of the secrets in this path, tenants demo DB, the application is given a read permission if the application has this SPIFFE ID, and similarly for the same path, the application has been given a write permission if it has this SPIFFE ID. That's how you define policies as a super administrator on the Spike system. And also you can like do multiple, like you can create a read and write permission all together in one batch instead of doing it separately. Essentially, all of those policies are unioned, and you get like an aggregate of all of the permissions that you give to the application. So whenever you create a policy, assume that like it will be combined as a union operation. And also, if you don't have a policy, you can assume that the workload won't be able to execute any operations, because anything is denied by default. You need to explicitly allow read and write operations to paths and to SPIFFE IDs for those operations to work, essentially. Okay, that's the policy part. So let's try creating it and try running the binary again and see how it works. I'll do make demo create policy. It creates those two policies that I showed you. And when I run demo application right now, I am able to like read the secret that we created. And to go back to the source code of the demo application, here we create a secret, and then down here we read that secret that we created in the same application. We are able to do it because we have defined policies for the demo application to write secrets and also read secrets. Okay, so Those are the new things that we have introduced, and it will be part of the Spike mainline real soon, like within a couple of hours. But I just wanted to introduce you those. And as far as policy management and also using make files and the new make commands goes, that's all I have for now. And until next time, keep your secrets secret.